am Kræn, and I work as a developer experience engineer at ElevenLabs, and I help build SDKs for people building on top of what we're doing. Just a very quick, just very briefly about ElevenLabs. We are this AI research company, product company, transforming how businesses and organizations communicate with their customers and with the world in general. So we do this through our industry-leading AI models that you can use to build different things. We have a couple of verticals inside the company. So one is the 11 Creative Suite. It's about a lot of tools that you can use as a creator of different types of content. That can be text-to-speech as you're having your content read aloud. You can do dubbing. You can do generation of music, videos, images, stuff like that. Yeah. And then we have the agents platform, which is when we take these models, a speech-to-text engine and the LLM, and then text-to-speech, you can combine them into one coherent agent that you can have conversations with. This is what I'm going to be talking about today. And then for all of the services, all the UI that we have, we also have API access. So everything is built in a way that you can interface with as well. Cool. So I need a volunteer, somebody I can talk to, somebody that speaks English. Anyone? Okay. So can I ask you, what is your name? Okay, and where are you from? Okay, that's great. Anybody notice any weirdness in that conversation? Yeah, did you notice anything weird in the way that I had this conversation? Or did you notice anything weird? I waited, that's true. Yeah, like I was thinking, or I was hesitating, right? So there's this study many years ago in the Netherlands about how humans interact. And the mean time that was discovered is like around 200 milliseconds from somebody posing a question to somebody answering. It starts having, that's like the 200 milliseconds is the norm. And when it approaches like 600 and 700 milliseconds, it becomes more, not just a delay, but actually it feels more hesitant. So that's a thing that we want to be cautious about when we are doing stuff with voice and mimicking interactions. Yeah, so this way. So I want to have you take away from this session here. I want to have you know more about what to look for. What are the trade-offs when you're building with voice and voice agents in particular. So you can also apply this knowledge when you're building or exploring different options. That's my intent. So the classic approach to building voice agents is this, we call this the cascaded model, is where you have speech to text, and then you have like a language model, a text-based language model, LLM, in the middle, and then we have text-to-speech on the other side. And then you have some kind of transport that you use to communicate over. And all of this adds up in a very naive implementation with cold starts from the LLM. You can reach like multiple seconds of round trip, which has issues when you do the communication, right? So the premise of this talk is like, how can we tune? How can we cut? What can we do to make this better? And better is not always smarter. There's one approach could be like, we just dial up the numbers, like make the LLM smarter, then it's going to be better, right? That's not always the case. It will give a brilliant answer, but it might take too long for a real-time communication to really be fluent. And also faster is not always better, right? Because then it might be making mistakes in the when it's trying to understand what was said, or as it's generating a response, maybe it's not a good response. So it's always about turning the knobs and like knowing when you can sacrifice intelligence for speed. So we start with the ears of the beast. It's the in this case I'm mentioning Scribe v2 real-time, our speech-to-text model. It already here we can get better latency, and it also has detection inside about the voice activity detection on when is users actually not speaking. We also have, I'm also going to get more into this, but we have details around it knows the difference between somebody saying yes, like affirming, or somebody saying yes as a final thing. Like so there's also intelligence built into the actual speech to text. Cool. So you can also, if you don't know your audience, like who is actually going to be talking to the agent, you might be tempted to add, use multi-language models. We also support that, many languages, but it also adds latency because the model needs to figure out what the language is actually being spoken. So that's something. So if you know exactly what audience that the agent is supposed to be talking to, it might shave off latency if you can actually pin it down earlier. And then for the brain of the thing, this is an approximate number, like 40 to 70% of the effort is like spent in there, and there's like a lot of room to cut. So basically, you can go from something very faster. So these numbers that I'm showing here is like a cold start. So it's not super representative of an actual conversation where you have multiple turns. But you can see here, we go from Kræn to GPT Nano, Claude Sonnet, a little more intelligence, smarter, and then Opus, for example, as a very smart model, but also slower in the round trip time. And also it has a cost associated when you start dialing this up. So I think the main takeaway here is that you wanna potentially start fast, and then escalate when you have a use case that requires more intelligence, you add that in. And this is also, so you basically start with a fast model, and then you can have a decision point in here. It could be like as you're configuring the thing, maybe you realize that you need more smartness, or you can also leverage in our platform, you can have a graph of different sub-agents where one agent is running with a fast and less smart model, and then you can you have an instruction telling when it transitions into another node of the graph where suddenly the agent becomes more smarter. Let's say that you have an agent that just picks up the phone and starts a conversation, but then it realizes this user actually wants to retrieve like an offer on something that takes more effort, basically. Then you can transition in and spend more credits in the intelligent part without enduring the cost every time. Yeah, is what we call agent workflows. Okay, so let's try this. I want to show first, we take a very fast model, and then you can see as I stop speaking, you can see a timer, and then when the agents respond, you can see exactly how long it took. And we're also doing this on a conference. I am wired now, so it should be fine, but let's see. Yeah, so I'm gonna ask some questions. Hey agent, can you tell me how many S's are in espresso?
There are 2 S in espresso. Let's get this show. Awesome. What else can I help you with today?
Can you tell me how many L's are in espresso?
There are 2 L's in espresso.
Okay, so how about now? Now you're Claude Opus. Can you tell me how many L's are in espresso?
0 L's in espresso, my friend. Just a double shot of S's, keeping it caffeinated.
A double shot and an S more. But anyway, so you get the point here, right? It's a little more smart. So another thing you can do is for the LLM part, the brain, right? You don't want to have the LLM just completely unconstrained where you can ask it to do whatever, give you a recipe for bolognese or start asking it to generate code or something like that. Or if you're an insurance company, like a bank, if you're a bank, you might not want to have the LLM give financial advice, for example. So there might be some guardrails that you want to put in so you can restrict how the agent is used. And if you don't have the guardrails, then it's potentially faster, but also it can be very priceless if you mess up. And there are different approaches here. We have a streaming solution where the agent is basically, it's allowed to talk, and then another component, another language model is basically surveying it. And then if it says something it shouldn't, then it gets cut off. But it might actually have said something that it shouldn't at the point where it gets cut off. Or you can add latency, where you basically put a blocking into the pipeline where everything needs to be validated before it exits the pipeline. So it adds latency, but then it also, you're more sure that it's correct, basically. Again, a trade-off here. Yeah. So what was the last link? Yeah, okay, the blocking. So now for the text to speech, right? Let's see what comes out of the other way, the other end here. So you can go again, you can go fast. and it's great for getting some. That's the two examples that I showed so far, is using a fast model. Or you can have it more expressive, where you allow the LLM to express itself more. It can output tags like whispers or yells or laughs and stuff like that. So you get a more engaging communication, but it also, again, it adds a little more latency. Yeah. So when you talk, right, you start the call, it's silent. The user, you start speaking, and then you wait in silence, and then the agent responds. So there might be points here where you don't understand, like, am I connected, or like what's happening, right? And if you want to be expressive, so you cannot afford getting the lower latency, you can do other things to signal that the connection is there and like the agent is ready. And you can, for example, add a greeting in the beginning of the conversation where you're not actually using the LLM to generate the greeting. It's a deterministic start of the conversation that can happen instantly before the LLM starts up. So that's one way of doing it, and the LLM would be aware that it actually greeted as a part of the pipeline, right? So that's one way of doing it. And then for the silence in between, you can add filler, like a background noise of a restaurant, for example. If you're a restaurant agent that takes calls on a restaurant, right, you can hear the back chatter, or you can, as I'm asking the agent to look up something, it can click on a keyboard and sound like it's actually doing something, right? So that's another way to add filler that makes it more natural, even if you have the latency. Good. Then for turn taking, yeah, that was the thing I alluded to before. Is the difference between saying yeah, as in yeah, you like continue, right? Or yeah, that's the thing I want. The turn taking here needs to be smart, because if the turn taking is, I don't know if exactly, no. Yeah, the thing is, if the turn taking is too aggressive, the turn stops and the user gets interrupted by the agent. That's not good. If you have a too loose of a turn taking, the time, it adds latency because the agent needs to be absolutely certain that the user is done talking before it starts talking again. So there's like an added pause in that. So tuning these parameters is important. Yeah, and we have different modes for configuring this thing internally. And as I said, ScribeV2 here has this tonal and rhythm also inside it. Okay, then we have something else called speculative turn taking that we also have in the platform, is where the LLM will get kicked off and start generating the response before it's actually certain that the user has is done speaking. And then if the user continues speaking, it throws away the result and starts again. This adds a little more cost because potentially like you're generating stuff that doesn't get read out, but you also basically, you can start the LLM before the user is done, right? Very fast. So you can shave off some latency here. And this is enabled in our expressive v3 by default. Okay, let's go for it. So I put together another agent here that has all the bells and whistles of what we just talked about, and let's see how that works.
Mic check, 1, 2. Okay, I'm on. I'm turned on, and I was born ready. Fire away. Estoy listo. Disparen.
Can you tell me how many L's are in espresso?
2 L's? 0, my friend. It's ESPRESSO. No L's in sight. Just like Express, but with more caffeine and Italian flair.
That's great. So can you tell me maybe, something, no, wait a second, can you try talking again? Oh, it's a bad prompt. Anyways, can you do something in the background just for a second or two?
Let me pull that up real quick.
Okay, that's great. And can you laugh?
Of course I can. That's what happens when you're built by people who actually care about personality, not just robotic efficiency.
Okay, that's great. Can we talk about kittens? Because I really like kittens. Okay, we couldn't. Anyways, so this was the final demo. So there was like a lot of different things happening here, but I hope that you get the point that like having this was like a music track, but it could be a restaurant, right? Or it could be something else. And all the guardrails here in the end triggering because I talked about something we couldn't. Or actually, it's because the LLM started generating something about kittens, and that's why it got cut off. Okay. So when you want to get access to this, because this was the entire pipeline, we have the 11 agents as a cohesive platform where everything is built in. And then it used to be the case that, and you can still do this, you can roll your own where you can take the speech to text and text to speech and then combine them in your own infrastructure. But here you need to take care of turn taking and the transport, and you also need to provide the LLM. And I would say the turn taking and transport and like setting that up correctly also like it adds latency, but also it's complicated, right? So for customers that already have an LLM, a chatbot, for example, where you can communicate with text, we also built and shipped this just a few weeks ago, the speech engine, where you basically, the brain lives in your own infrastructure, and the speech to text, text to speech, and turn taking, all that is handled for you. So this is like a thing, like a middle ground, right? The architecture here is a little more technical now, but so the browser basically connects into ElevenLabs infrastructure, the user's browser, right? And when they speak, the speak is transferred into our speech engine SDK here. It says your server, it's meant to be our server, right? And the conversation here, no, sorry, that's not correct. The you server here is your infrastructure, sorry. So anyways, ElevenLabs connects back into your server running the speech engine SDK, and then the conversation history is transferred into your LLM of choice, and you can stream your responses back from the LLM, which is then sent into the ElevenLabs infrastructure, and then is read aloud inside the browser of the user. Does it make sense? Yeah. Okay, that's good. So and this is an example of like setting it up. It's pretty simple. You just use the ElevenLabs SDK, you create a speech engine here, and then on transcript, every time something is transcripted, you send it off to your, in this case, OpenAI. You try to get some answer back, and then you send it back to the user to be spoken aloud as it's done. Okay, this is a little, again, in the ideal conditions, you can get faster. Like the last example that we had here, I had all the dials turned up, right? So it was a little more, took longer time. But if you really cut it down, you can get pretty good latency. But this is an area of active research. This is something that is being worked on. But I think the takeaway here is also there is ways to fake it in a way, like where you make it feel more responsive, even if you don't have those like super snappy all the time. If you need that expressiveness as well. Cool. So this is a QR code that I think you should scan if you want to try it out. It gives you 3 months of Creator Plan that you can use to try out both the 11 Agents platform, but also the 11 Creative platform. Yeah, and it needs to be redeemed within a week. But yeah, cool. Do we have any questions for what I just told? Yeah.